Hi, welcome to your MECH 200 Statics online classes. This is the fourth video of Chapter 4, in which we continue studying the different aspects of force system resultants. I hope you enjoyed this class. We're going to start this video by introducing the concept of moment of a couple, or the moment created by a couple force, which is defined as two parallel forces that have the same magnitude but opposite directions and are separated by a perpendicular distance d. In this type of system, the resultant force is zero, and then the only effect of the couple force is to produce a rotation or tendency of rotation in a specified direction, which is identified by the couple moment m. To illustrate this concept, imagine that you're driving a car with both hands on the steering wheel, and you are making a turn. A couple moment will be produced when one of your hands pushes up on the wheel, while the other hand pulls the wheel down, which causes the steering wheel to rotate. Using the scalar formulation, we can determine the magnitude of the moment of a couple by multiplying the magnitude of the force and the perpendicular distance or moment arm d between the forces. Just like any moment, the direction and sense of the couple moment is determined by the right-hand rule, which indicates the rotation caused by the couple forces. In all cases, the couple moment will act perpendicular to the plane containing these forces. Using the vector formulation, we can determine the moment of a couple by finding the sum of the moments of both couple forces about any arbitrary point. For example, if we want to find the couple moment about point O, and the couple forces are applied at points A and B lying on the line of action of the two forces, then we can define the position vectors RA and RB directed from point O to points A and B, and the distance vector r between A and B will be the moment arm of the couple forces. Then, the couple moment arm about O is calculated by the cross product between the distance vector r and the couple force F. Now, let's talk a little bit about the concept of equivalent couples, in which two couples produce a moment with the same magnitude and direction. For example, if we have a couple force of 30 newtons acting at a perpendicular distance of 0.4 meters from each other, it will produce a moment with magnitude of 12 newtons meter, which is equivalent to reducing the perpendicular distance to 0.3 meters and increasing the force to 4 newtons. Those two moments are equivalent and directed into the plane of the page according to the right-hand rule. You can notice that a larger force is required in the second case to create the same turning effect because of the fact that both hands were placed close together. Another important aspect of coupled moments is that they are vectors, which allows us to calculate the resultant by vector addition. Let's consider, for example, that we have this pipeline here in which two couple moments M1 and M2 act to create a rotation effect in the structure. Since each couple moment is a free vector, we can join their tails at any arbitrary point and find the resultant couple moment MR, which is given by this equation right here. If more than two couple moments are acting on the structure, we can generalize this concept and write the vector resultant as in this general equation. Now, let's illustrate these concepts numerically through one example. In example 4.10, we have to determine the resultant couple moment generated by three couple forces acting on the plate in the figure shown here. The three couple forces as defined as F1, F2, and F3, all of them with known magnitudes. To solve this simple 2D problem, we should use the scalar analysis in which we also need to consider the perpendicular distance between each pair of forces. For the coupled force F1, we have the distance d1 of 4 feet that causes a clockwise rotation tendency, or a negative moment. For the coupled force F2, we have the distance d2 equal to 3 feet that causes a counterclockwise rotation effect, or a positive moment. And lastly, for the coupled force F3, we have the distance d3 equal to 5 feet that causes a clockwise rotation tendency, or a negative moment. Then, considering the scalar formulation, we have that the resultant couple moment is given by the sum of the 3 individual couple moments. And after replacing all the values given in the problem statement, we have the final answer that is negative 950 pounds-foot, or simply 950 pound-foot clockwise. It's your time now to go through examples 4.11, 4.12, and 4.13 of the textbook on your own. Before you do that, make sure you fully understand how to calculate the moment of a couple and the resultant of couple moments using both the scalar and the vector formulations shown in the previous slides. And with that, we are done with part 4 of chapter 4. Thanks for watching, and I'll see you in the next video.